Friends of Black Rock, High Rock, and I am the ED for about a year and a half plus, I guess. So this is my first virtual Black Rock Rendezvous, but not my first Black Rock Rendezvous. I think been coming out to the Black Rock Desert since I was 16, but really got hooked because of the rendezvous and listening to great presenters and speakers. And I'm so glad that we're able to continue that tradition now, though in slightly changed format. So I'm here with Cathy Busby, and Cathy, I had the good luck to meet at Earth Guardians last year at Burning Man. Cathy gives a presentation. I think she gives a season, so to speak, of this presentation. And I remember that day really clearly. It was very hot, much like today. And Cathy was able to take us from the heart of the Playa in 100-degree temperature all the way back a billion years to where we were deep under the ocean, and Australia, the Antarctica Rift started moving westward, and kept up that tradition of talking about the geology until we were a mere 15,000 years ago, when we were 500 feet underneath Lake Lahontan. It was very cooling. I remember that and appreciated that. So Cathy is very distinguished, and I want to embarrass her a little bit. She has a PhD from Princeton in geology and is a professor emerita from UC Davis with 38 years of teaching under her belt, and manages to balance a world of teaching with field work in the Sierra Nevada range, where she's studying earthquakes, and the Baja, where she is studying continental or researching continental rifting. And probably, I imagine her in my mind's eye, riding over 4x4 passable roads, studying rocks, or sea kayaking, or snorkeling in the Laredo Marine Sanctuary. So if that's not enough to make you jealous, I believe that Cathy just came back from a year sabbatical in Spain with spending time with her daughters and flamenco dancing. So with no further ado, we're ready for a really fascinating trip through geological time of the Black Rock. Thank you, Cathy.
Thank you. Okay, so let's see. Okay. So when I'm talking, aren't I supposed to be showing up? Because I see you still. Can you hear me?
I can hear you and I can see you,
Okay.
and I can see your shared screen, and maybe I'll ask Chris to just pipe in and make sure that's technologically up to, that's good for everyone else too.
Yeah, looks good on my end.
And so when I'm looking at you guys, it's not covering up my slideshow, right?
No, you're fine. Okay.
Okay, good. All right. All right, well, so first I want to say that this isn't just my talk. It also has contributions from Professors John Dillis and Anita Grunder at Oregon State University. And they're shown here in the Leopard Martini loungewear at Burning Man. And also Elizabeth Miller at Stanford University, who's standing with me there. I'm in the pink dress. And she's done a lot of geology in the Black Rock Desert. And then this is me up here. I made my pointer really big. Can you all see it? This is me up here on my way into Burning Man with my purple hair and my purple leopard print scarf. And UC Davis is very supportive of this. When we have picnic day once a year, they put up posters about all the faculty. And here is a poster about me going into Burning Man. And it also talks about working in the desert, which I've done a lot of. So we do geology talks and bicycle tours. The bicycle tours are two times during Burning Man at dawn. And it's beautiful to get out there on the Playa at dawn. And then also I do 2 talks around the middle of the day in the Earth Guardians pavilion. So leave no trace. And if you want any more information, email me, cjbusby@ucdavis.edu, or you can go look at my website at Santa Barbara, where I just retired from, and see more. Like I have a Black Rock outreach PDF on there. Okay, so
Kathy, can I
Right.
interrupt for just a moment? I forgot to mention, and I want people to know this right off the bat, that you and I talked earlier, and you're very happy to field questions as we go along. So please, if you are watching and want to stop and linger on anything or have a follow-up question, please go ahead, and I will make sure that that we get it answered.
Yes. Okay, so I'm pretending that we're on the playa. In fact, I joined a Facebook group called Where People Pretend They're at Burning Man. And we post things as if we are at Burning Man. So here is where Burning Man is on the Black Rock Playa. It's the largest playa in North America. And a playa is a flat bottom depression. Usually it's a dry lake bed that makes such a flat bottom. And on this playa is where the land speed record was set in 1997 with a supersonic car. And the reason they could do that is because it is perfectly flat. So if we go back 15,000 years ago, the climate was much cooler and wetter because it was during the last glacial advance, during an ice age. And because the climate was cool and wet, there were a whole series of lakes, and one of them was called Lake Lahontan, and it covered the northwest corner of Nevada. It was 500 feet deep in the Black Rock Desert, and the earliest humans lived on its shores. Now, today, of course, it's quite arid and dry, and the glaciers have melted back, and it's gotten hot and dry. And so if we look at the Black Rock Playa today, there's the Black Rock Playa, and the original Lake Lahontan was fed by the Humboldt River, which came in up here, and then when the drying up happened, the Humboldt River switched to go into the Carson Sink. So now the Black Rock Playa is fed by the Quinn River, which starts out in Oregon and then comes down into the Black Rock Desert. So if you're at Burning Man, I would say, if I was at Burning Man, I'd say, oh, look to your west, and you can see these lines in the mountainside exactly to the west of us at Burning Man. And these are old shorelines. So the lake level used to be up here, and then it dropped down to here, and it dropped down to there. And you can go climbing around on those old shorelines, and there's beach gravels and shells from the lake. So that shows you the last high sea level, lake level stand, and then it dropping. And also, there's a beautiful set of they're called the high dry micro playas. So here is the Black Rock Hot Springs right here. And it's right by the Black Rock, which we'll get to later and find out what it's made of. But lake level used to be up to here, and then when lake level dropped, that playa dried up. Lake level then dropped down to here, and then that playa dried up. Then you can see all the shorelines from lake level dropping even more, and then there's no lake now. It's just a bit of a pond in the winter. So what we are in the Black Rock Desert is what's called the Basin and Range. And this is a place where the continental crust has been stretched in an east-west direction. And so what happens when you stretch continental crust is that blocks drop down and form what are called grabens. And they drop down on these faults that are called normal faults that drop the blocks down, and the high blocks stay standing. So what's happened in Nevada is actually, it used to be half as wide as it is today. And it's been stretched so that it's now twice as wide as it was 25 million years ago. And during that stretching, you drop down these grabens. So for example, here is a mountain range that makes a horst block, which is the upside. And then the fault runs along the base of the mountains, and then the graben is filled with lake sediments, which is shown here. So here's a satellite view of the Basin and Range. And so here is basically Nevada. and the Black Rock Desert is up in here. And what we're looking at is all the mountains and basins that have formed by this stretching. And it's been said that it's like it's like worms crawling north to Canada. And all of these ranges, which you can also see in this geologic map, are bounded by normal faults. So I showed you a graben that had equal faults on both sides. Another possibility is that a graben is more like a half graben, where it has a very big fault on one side and either no faults on the other side or small faults on the other side. So that's a more asymmetrical basin, and you get thick accumulations of sediment in the basin next to the big active fault. And the lake is more over on that side too, because it goes down really fast and you can't keep it filled with sediment. So at Burning Man, there you are, where the red star is.
Cathy, can I ask you a quick question? I get this a lot. I've heard this asked a lot, at least.
Yes.
So because of the fault shifting, there's different layers or levels of sediment in that lake basin. Is that true? How deep?
So, well, I'm going to get onto the sedimentary fill of the basin on the Playa, but it's many thousands of feet of sediment that have accumulated because of this dropping down. And anybody else, ask questions. I'm having my happy hour. My vodka, I was told this is happy hour, so I'm having a vodka tonic with lime.
Yay. Well, Cathy, I do have, it's more a comment than a question. From, and Frederick, if I totally slay your last name, forgive me. But Frederick Least, and he says, hi, Cathy, I took geology from K. Deffies, probably spelling his name wrong, at Princeton in 1970. At Black Rock City, I get drafted to hold your posters while you are speaking.
Wow, you took geology at Princeton in 1970? Because I was there I started there in 76, so I just missed you.
Very cool. Very
yeah.
cool. You got a fan.
Thank you, thank you. So this is a close-up of the Black Rock Playa, and one thing you can see here is these red lines show where the Black Rock Fault is, and partly it's buried under the sediments of the Playa, but this side is dropping down, and this is a Landsat image from July 11th showing some water in the Clyde River sink, which is kind of late for having water. That was pretty amazing. So what is the Playa made of? I'm starting out with the really young stuff, and then we'll go back and look at the old history. So the Playa is mainly made of clay. It's 65% clay, but it does have silt, a lot of silt, and then sand. So that's why we get those big dust storms, because it's mainly really fine material that falls out of the river on a really low gradient. So it's not coarse material at all. And the clays are mainly smectite, which is a clay that forms by weathering of feldspar. And then when it gets wet, it swells, and when it dries, it shrinks. So that's why we get all those beautiful cracks. And there's a picture of it inundated with water in the winter. So one thing we really love about the Black Rock Desert is the hot springs. And this is a major feature of Nevada, because there's what this map shows in red is areas of high heat flow. So coastal California has low heat flow, but when you get into the Basin and Range in here, there's high heat flow, and it's hot, and the continental crust is really thinned by this stretching, and there's these normal faults that penetrate very deeply. And so what that means is that you can collect water in the sedimentary basin. So here are these normal faults stepping down. Here's a sedimentary basin, the Fernley Sink, the Carson Sink. And what sink means is it's an enclosed basin. The water can't flow out to the ocean. It just goes in the middle and evaporates. But some of it percolates down into the sediment. And then when it percolates down far enough, this is a fact about the Earth. As you go deeper, it gets hotter. So you don't need magmas down there to make the water get heated up. It's just if it can percolate down far enough, it will get heated just because things get hotter as you go down. And then hot water rises, but it likes to rise along faults. So the hot springs are mainly along these big normal faults of the Basin and Range. Here's a close-up of the North Pyramid Lake geothermal field. And again, you can see this hot area coming up the normal fault, and that's just hot water coming up that fault. And then at the surface here, there's a little blip, which is a tufa tower. And those of you who have been in this area know that there are these tufa towers all over the place. And they form where the hot water comes up under the lake, under lake water. And the springs come up into the lake, and the lake is full of CO2, full of carbonate, because it's an alkaline lake. So when the springs come up into this lake water, they precipitate limestone. So that's what these tufa towers are, is limestones that mark where springs are coming up under the lake. And then if lake level drops, they're more exposed.
So Cathy, I have a question again.
Yes.
Frederick asks, can the path of the Yellowstone hotspot be traced as far west as the Black Rock Desert?
Yeah, so the Yellowstone hotspot trace began up at McDermott, which is just outside, it's in Oregon, but it's very close, right? Well, McDermott is, yeah, very close. And I actually had something about the Yellowstone hotspot in this talk, and then I thought the talk was getting too long, so I took it out because we don't really see those rocks right in the Black Rock Desert. But yes, yeah, that's part of the story. So what I want to do now is go back 1 billion years and see how Nevada was constructed over the last 1 billion years. So we're going to start with the oldest rocks and work our way back to the recent, which is the Playa with the sediments today. So this is Fly Ranch, which I've had the great pleasure of getting to visit with Friends of the Black Rock last spring. And I just wanted to advertise Friends of the Black Rock High Rock.
Well, if I can, after this, you're gonna have an opportunity, if you guys are still watching, and continue to see a virtual tour of Fly Geyser too, if you haven't had the good fortune to see it yet. I think we've got an interesting presentation to follow on the Fly Geyser.
It's very beautiful. Now, it's not a natural geyser. It was a geothermal prospect well that wasn't capped properly. So but it's made a beautiful formation. I mean, it's gorgeous. And there's a nice hot pool there. That's really fun. Okay, so this is where the Black Rock Desert was 1 billion years ago, where that red star is. And 1 billion years ago, believe it or not, Australia and Antarctica were next door to us. And it took a long time to figure that out, actually. I think it was only figured out about 20 or 25 years ago that is what happened. So what happened is here was the western side of North America, and here was the eastern side of what became Gondwana, and which is a combination of Australia and Antarctica that were next to North America. And they stretched apart and rifted apart and made a new ocean basin. And then seafloor spreading rafted them apart. So it's like the Gulf of California. If you go down there, there's lots of islands in between Baja California and mainland Mexico, because when you do that stretching, like we showed with the Basin and Range, you have lots of mountains and basins, and some of those are still sticking up as islands. That's pretty cool that we had Australia as our next door neighbor, and Antarctica. So then if we move a bit younger into the early Paleozoic, which is about 650 to 450 million years ago, the rifting was all done, and it turned into a very broad continental shelf, kind of similar to the Great Barrier Reef of Australia or the east coast of the Atlantic. It's called a passive margin because it didn't have any active faults. It was just a broad shelf that was subsiding slowly and collecting limestone. So here we are again in Northwest Nevada, and the continental shelf was collecting limestones. There was a continental slope going off into deeper water. Now, one of the reasons that those limestones are interesting is that even though they formed in a very tectonically passive environment, no volcanoes, no faults or anything, about 400 million years later, they got invaded by some magmas, and those limestones host the Carlin gold deposits, which maybe some of you have heard of. It's this whole area in this part of Nevada that is produced by hot waters from magmas that circulated into these really old limestones along faults, along the Basin and Range faults, and made the second largest gold deposit in the world. So the limestones are cool. And if people like fossils, the limestones are cool for that too, the Paleozoic limestones. Okay, so we had this tectonically very quiet area until later in the Paleozoic, near the end of the early Paleozoic. And then a chain of volcanoes formed. Shouldn't point at the screen. There we go. A chain of volcanoes formed that were related to subduction. So these were a chain of volcanoes, and I'm just going to show you what subduction looks like. So with subduction, you have one oceanic plate going down, diving down all the way into the mantle. And this subduction can go down into the mantle, eventually all the way to the core. And it can go under a chain of islands in the ocean with a sea separating that from the continent, or it can go under a continent, the subduction. So what we're looking at in the Paleozoic is subduction going under these oceanic arc chains. Later we'll see the example of the continental arc. So here's this, it's referred to as the antler arc, and it was out here in the ocean. Here's North America. Here's basically the edge of the continent. And subduction under that arc made the arc get shoved up onto the continent along thrust faults. And that happened not once, but twice. It happened in the antler orogeny in the middle of the Paleozoic, and then it happened again in the Sonoma orogeny at the end of the Paleozoic. And these oceanic volcanoes got shoved up onto Nevada, and the red star there is meant to show you the Black Rock, because the Black Rock, for which the Black Rock Desert is named, is a volcanic rock from Sonoma, the island arc chain that got shoved up onto Nevada. And I have a piece of the Black Rock in my bedroom on my nightstand. It's very pretty. It's very black.
You may have that.
What?
You're welcome.
I always bring it to Burning Man and pass it around. So here's the Black Rock, for those of you who have been there, and it's part of this Sonoma oceanic rock assemblage. So it's a Permian volcanic rock, probably a shallow intrusion. And it's fun to climb up to the top of it.
That's a good hike.
Yeah, and you got a good view. So now we're moving on to the Mesozoic, which most of you probably know is the age of dinosaurs. And in the Mesozoic, subduction began under the edge of the North American continent. So here's the Proto-Pacific plate subducting under there. And when the plate subducts, melting occurs and you form volcanoes, which I'm showing here. This volcanic chain that was in the Sierra Nevada and bent around to come up here in the Black Rock area. So there's the red star again for the Black Rock Desert. And so the volcanoes are at the surface, but underneath is way more magma that cools at great depth, many kilometers below the surface. And these are called granites. And that's what you mainly see in the Sierra Nevada, but they're in the Black Rock Desert too. So if you look at the Granite Range, aptly named, and Granite Peak, those are right by Gerlach. And those are the Mesozoic granites that formed by subduction under the continent. And a lot of people like to climb Granite Peak. So these Mesozoic granites, formed, this is this red thing labeled batholith, like 10 or 20 kilometers down below the surface and fed volcanoes at the surface. But then the whole western part of North America here started getting put under compression, where there was a huge mountain building event. And these compressive forces produced something that's referred to as the Nevada Plano, which is, it was named that because it's kind of like the altiplano of the central Andes, where you have a very high mountain range and then volcanoes on top. And so the Nevada Plano, its crest was here in eastern Nevada, and then canyons were carved into it going west and going east, and there were all these thrust faults from the compression, but all that uplift exposed these granites that were formed 20 kilometers down. So it was a lot of uplift and erosion. And so the Sierra Nevada granites got exposed, and the granites in the Black Rock got exposed by this mountain building event. So this huge mountain range formed, and then whoops, you turn around and you stretch it. So the Nevada Plano was stretched, and the grabens dropped down and produced what we see now, the Basin and Range, with these mountains in the horse blocks and the grabens filled with volcanic and sedimentary rocks. And that brings us back to the present, more or less. So what the last thing I wanted to do, besides having another sip of my
Cheers.
I wanted to talk about earthquakes, because we've had some earthquakes lately. And so I put together a few slides to talk about that. And so where are the earthquakes happening now, and what kind are they? So first of all, we know about the San Andreas fault zone. That's a very active fault, and it's the boundary between the Pacific plate, and we used to think that when you cross the San Andreas fault, you were on the North American plate. We thought that 20 years ago, but now we know that's wrong, because there's a microplate in here. It's called the Sierra Nevada block, or the Sierra Nevada microplate. And we have all these earthquakes that come up out of the Gulf of California, through the Eastern Mojave, and up through what's called the Walker Lane, which goes right through Reno.
Oh, nice.
And then goes out by Lake Tahoe. And basically what's going on is that the Pacific plate, shown here in blue. So if we look, this is the coastline today. So we're looking at from the Bay Area down to Santa Barbara, and we've got part of the continent on the Pacific plate. We've got Santa Barbara and LA on the Pacific plate. And then here's the San Andreas Fault with 4 centimeters a year of movement. And then we've got this Sierra Nevada microplate. And then we've got another fault zone called the Walker Lane. And that has about 1 centimeter a year slip. So it's less slip than the San Andreas, but it means that the Sierra Nevada block is going north independently of the Basin and Range and the Pacific plate, just a slower rate than the Pacific plate. And that was first figured out by Global Positioning System, GPS. People put in GPS stations that were permanent stations and record movement over the period of years. And then they can detect movement of the Earth's surface. And so here's the coastline of California. And you can see that there's a big, this is the Walker Lane. And you can see that there's a lot of northward movement relative to Nevada in the Walker Lane. So people that thought they were safe leaving coastal California and moving to Lake Tahoe or Reno or something, no, there's faults there too, as we've been finding out. So, oh, and then here's the position of the earthquake that happened on May 15th. The biggest quake in Nevada in 50 years.
Wow, and that was around Tonopah, is that?
Yes, yes. It was 30 kilometers west, or 30 kilometers west of Tonopah. So I'm going to show you why there was an earthquake there. First I'm going to just tell you a little more about the Walker Lane. So the Walker Lane, if you look at the Gulf of California rift, and Baja California rifted off of mainland Mexico about 6 million years ago. So Baja California has been transferred to the Pacific Plate and is moving north, along with this part of coastal California, Los Angeles and Santa Barbara. But the San Andreas Fault takes a big bend here in the vicinity of LA, which is why LA has so many dangerous earthquakes there. It's locked in that area. But if you follow the Gulf of California straight up, you go into the Walker Lane. And what it's trying to do is, if you could think of it as having wishes and desires, it's trying to straighten out. So Baja got plucked off 6 million years ago, and it's trying to straighten out so it just goes straight up here. So it's referred to as the future plate boundary, and it's inferred that the San Andreas Fault will be abandoned, and all of the faulting will take place here in the Walker Lane, which is, the San Andreas Fault is just strike slip. I'll talk about that. The Walker Lane has strike slip and pulling apart, which is what you need to pull the continent apart. You need the rifting. So the rest of California is going to be plucked off. And then this is the view 10 million years from now, when California is getting plucked off of Nevada, and there's a seaway in here, and California is moving away and north with respect to Nevada. But
California, where are you going?
They're going north and away. So it's mainly north, but a little away. And so beachfront property in 10 million years in Reno.
I'm looking forward to it.
So if we look at the Gulf of California, the Walker Lane is what's called a transtensional rift, like California. And what that means is that it is pulling apart and sliding sideways. So it's not just pulling apart, and it's not just sliding. Yeah, Chinese. And it's not just sliding sideways. A dog walked by. How dare they?
That's kind of
it's doing both. But so what the faults look like in the Walker Lane is that there's a whole series of right lateral strike slip faults like the San Andreas. So if we look at right lateral, what that means is that this road is displaced to the right. If you stand on this side and look across the fault, you can see it's displaced to the right. And then a left lateral fault is displaced the opposite way. And so what we have in Walker Lane is a lot of these northwest faults that are right lateral strike slip, but then we have some places where we have these more east-west faults that are left lateral. And those are just places where there's bends in the fault zones, which refer to as a step, a right step. So the fault zone's coming up here and it bends that way and goes on up. And it has to be accommodated by these left lateral faults. So the reason I'm worrying so much about the Mina deflection here, here's Mono Lake, so you know where the Mina deflection is. And the reason we're thinking about this is because that's where the earthquakes were last week. They were in this bend, and they were left lateral fault slips. And there were a whole bunch of them, including the 6.5. So there's Mono Lake again.
So each of those yellow dots is
an earthquake.
Is an earthquake. Wow.
Yeah,
okay.
There were a lot of earthquakes. Yes.
And this is a span of what? This was?
A few days.
Wow. Okay.
Yeah. So now here's another aspect of the Walker Lane. And the reason I'm talking about the Walker Lane is because the Black Rock Desert will be beachfront property when the Walker Lane pulls California off Nevada. But I'm also wanting to tell you about these recent earthquakes because they're in the Walker Lane where California's trying to secede from Nevada. And so here are the earthquakes we had last week by Mono Lake. And then if we go down to the Ridgecrest area, we had these earthquakes last July. And they were also in this Walker Lane fault zone, just further south. And again, just like I was talking about, we have these northwest faults that are right lateral faults and these northeast faults that are left lateral faults. And most of the bigger earthquakes were on the northwest right lateral faults, but there were also earthquakes on these northeast left lateral faults. And the thing that was also amazing about this series of earthquakes is that they hadn't really mapped a big through-going fault. There were just lots and lots of little ones that were mostly buried. And they all ruptured and connected up. And we used to think that you needed a big through-going fault to have a big earthquake, like a 7.1. We used to think until last July that the bigger the fault was, the longer the rupture could be, the longer the fault was, the bigger the rupture could be and the more energy released. But what we learned in this is that you can have lots of little faults that just all break through together and link up and make a 7.1. And that's what happened.
And that's a relatively new kind of...
That's a new concept as of last July.
Wow, that's pretty...
Yes. Yeah, so we're always learning new things in geology.
That's seismic.
Yeah. So I think that's it. Yes. So friends of the Black Rock, love Earth Guardians, please come join us if we get to go next year. You can volunteer. We have hot springs patrols. We have the Champagne Moot Patrol. We have a refreshment station with, water or alcoholic beverages. We have a stage where we have a lot of presentations. Look in the what, where, when to see which presentations you want to go to. And we hand out swag, like we silkscreen bandanas and moot bags and hand them out. And it's a really good group. It's very conscious of saving the Playa.
It is indeed. And I'll just add on, it was probably the most fun camp that we've been at and the most educational. I learned so much through the presentations and they were always delivered with this very kind of lightheartedness and kind of pleasure. And I think people sometimes at Burning Man are really starved for that interaction. A lot of people who come to Burning Man think of it as merely a backdrop for something else that, for the event itself. And, wake up one morning at sunrise, take a look around and go, wow, what is this place? And so I think Earth Guardian kind of fills in that wow, that question about what is this place all about. So I'm really grateful for getting to camp with you guys last year, and hopefully 2021 we will camp again.
Yes, and yeah, and I want to participate in more friends of the Black Rock. I enjoyed the film festival. When was that? January?
Yes, yeah, January. And if I can, shameless plug too, is that Cathy and Glenn Meloche came out and tag team a presentation for one of our Fly Geyser campouts, which was fascinating and fun. We had big hopes of having this presentation underneath the tent, and the weather did not.
It was a bit windy.
Windy and cold. And so we commandeered a bus and literally had a school bus presentation on hot springs and a billion years of geological history of the Black Rock, and people loved it. It was really, really fascinating.
And Glenn is a professional geothermal geologist, so he knows all about that stuff.
Yes, it was called Getting into Hot Water.
Yes. I learned stuff at that talk. It was his talk, that I didn't know.
I did have a question. So, and this is more of a hot springs question myself, is that, so when you were talking about the Horst and Graben and fault lines that come around where the Horst rises, is where a lot of hot springs occur then, correct?
Yes.
Yeah.
Yes.
So that explains, like, in terms of our Black Rock, Playa, why we have so much geothermal activity around the Playa, around that, which is definitely.
Yes. It's because there's a lot of normal faults, which those kind of faults are really good pathways for hot water to rise up. But also the whole basin and range has a high heat flow, so that helps too. Yeah.
So with this new knowledge of earthquake patterns and movement, has that going to bring a lot more energy into, like, the Walker Lane for people to do research? Because earthquakes are obviously a significant concern and interest for planners and city planners, as well as as scientists.
And so the University of Nevada, Reno Seismo Station is headed up by Graham Kent, and he's really, really good. And they've got a good group of researchers there, and they look at fault activity, and they make trenches across faults and try to figure out when they last moved and how much they moved, and what the slip rate is on various faults. And then they do geophysics to see the patterns of the faults underground. And one of the comments I saw that he made after this earthquake swarm we had last week is that Nevada's been pretty quiet for 50 years. But there's a hypothesis known as earthquake switching, where the earthquake focus could be quiet for a while, and then it gets locked, and then because the plates are still moving, so it must be locked, and then there might be a whole bunch of ruptures in fairly rapid sequence. So that's what he said, and people have also said that about parts of the San Andreas Fault, that there's locked sections like the Hayward section and the Palm Springs section that hasn't been having enough earthquakes, and we know those plates are moving, so we know they're building up and they're going to happen.
Well, this is a question, or maybe even a concern when people are coming out to the Black Rock area. Can a earthquake of even a fairly small magnitude change the temperature of waters?
No, that was in Dante's Peak. Well, no, that was, I guess they were having volcanic earthquakes or something. Not in a flash. No. It's not like you'll be sitting there in a nice hot spring and then suddenly you'll boil. No, not that quick.
That would suck.
It would be very slow. Yes. Yeah.
So I got a couple questions also, sort of in the Wayback Machine, to something that you were talking about with Carlin Gold. In the Black Rock area, I hope I'm asking this question right. Where is the Carlin Gold to be found?
Well, it's actually mainly just the Carlin Trend is to the east of the Black Rock. So yeah, Winnemucca, so there isn't, the Carlin Gold hasn't been discovered in the Black Rock that I know of.
Okay.
So, and where it's been discovered, it's been mined. So we're glad that the Black Rock hasn't been mined.
Yeah, no, truly. So again, then we'll send everybody else to the other spot. So where's the number one area in Nevada where the Carlin Gold?
Oh, the whole northeastern part of Nevada. There's
Wow.
a lot of gold mining in the whole northeastern part, but not really in the northwestern part.
Okay. So if Nevada's number 2, where's the number 1 gold region in the world?
I think in terms of the sheer amount of gold, it's the treasure of the Sierra Madre with Humphrey Bogart, which I've worked in the Sierra Madre Occidental in Mexico, like in Chihuahua, Sinaloa, and I was my research was supported by a gold exploration company.
Mm-hmm.
I didn't care about the gold. I just wanted to learn about the geology. They supported a whole PhD thesis and me, and paid for lab work and field work and everything to try to figure out what were the controls on where the gold formed. So that gold it formed about 50 to 30 million years ago. And again, it's along normal faults is what we can find, the stretching of the Sierra Madre. But that's the number one, the treasure of the Sierra Madre.
So for anybody who's a rock hound or is interested in gems, etc., that fault lines just generally where faults occur are probably rich areas for exploration.
Yes, because you get hot fluids coming through and producing silver and gold and copper and turquoise and yeah.
Nice, interesting. And it's a follow-up question here from Tara, because we do get a lot of questions, a lot of concerns. We do the Fly Geyser nature walks, and we do field a lot of questions about hot springs in general. So I want to be a little more specific with that. So an earthquake cannot necessarily change the temperature immediately, but can it have an effect in
over a period of time? Yes.
Right.
Yeah. And also, I mean, this is really Glenn's field of expertise, but faults can get cemented up because the fluids are moving through and precipitating things, and they can get kind of cemented up, and then the fluids will start going someplace else. But this is on this time scale of years, or decades. It's not while you're sitting in the hot spring.
Right. Well, from and I'm a novice to this, but just watching overall the kind of evolution of Fly Geyser, it changes, and it's interesting to see how it changes. But it's a multifaceted kind of phenomenon of that's happening there, I'm sure.
The colors are beautiful. I guess the colors are due to algae. This is not my specialty, but I guess the colors are due to different algae that are living in the hot water.
Well, you connect with our next presentation.
Yes.
And I did, and this is probably a little self-serving too, because I do remember hiking with you and Glenn after our camp out, and having a lot of curiosity about the tufa formations. And so the tufa formations, my understanding from what you said earlier, are kind of caused by faulting and down below in water that forces.
The tufa towers form where springs come up faults under the lake water. Mm-hmm. But then, when the lake was higher, like a lot higher, like, hundreds of feet higher, it was depositing tufa on the rocks, 15,000 years ago, it was depositing tufa on the rocks, 500 feet higher. So there's a lot of tufa coated all over the rocks where the lake used to be. Mm-hmm. The Lake Lahontan.
Fascinating. We were out on the Black Rock along Soldier Meadows Road and saw all these tufa formations, that small tufa tops that were kind of rising to the surface, or being kind of drawn in from flow, from precipitation and runoff. And it was fascinating to see them kind of uncovered and bubbled up from that. So.
Oh, you could see bubbling.
Yeah, well, yes. And so they were just emerging from where they had been buried through sediment.
Uh-huh. Oh, okay. They were getting washed, the sediment was getting washed off of them.
Okay.
Yeah.
Well, I'm getting the hook that we need to wrap up.
Yes.
But I want to tell you what a fascinating and wonderful experience this was, and that to remind people that this is recorded and will be available on our blackrockrendezvous.org site, and to stay tuned for the next presentation, which will be about fly geyser and will be equally fascinating. So Cathy, thank you so much. I look
Thank
forward to
you.
hanging out with you again and learning more from you.